Okay, I think we're ready to kick things off. My name is Robert. I'm going to be kind of hosting today. My colleague Grace Parks is going to be doing the vast majority of the presenting today. So I'm just going to kind of introduce today's events. This is the third iteration of CharityCAN's series, what we're calling AI Office Hours. What we're trying to do with AI Office Hours is just trying to explore what's new and exciting in AI and philanthropy, and AI and prospect research, and show you what we're working on a little bit at CharityCAN in regards to AI and philanthropy and AI and prospect research. And as I'm sure everyone knows, things are moving quite fast. So today, what we're going to be talking about mostly is tool calling, AI agents, and how we see things going, how we're using them here at CharityCAN, and maybe how you can start to think about them a little bit. So without any further ado, I'll kick things off for my colleague Grace, and Grace will take the reins and start the presentation. Thanks for joining us, folks. It's going to be a great one today.
Awesome. Thanks, Robert. Hello, everybody. I hope you're all doing well today. In today's webinar, we will be covering three key areas. The first one being the evolution from basic AI to what we're doing now, which is like tool calling, MCP or Model Context Protocol, and how that's standardizing AI integrations, and how reasoning models learn to use these tools effectively. Then at the end of today's webinar, we will also have a quick demonstration video that will be a little bit of a sneak peek into one of the new AI features that we've been working on. And we'll hopefully also have some time at the end for some Q&A and discussion. But if we do end up cutting it a little bit close to the end of the webinar without getting a lot of Q&A and discussion in, please feel free to leave any questions or comments that you might have in the chat, and we'll get some answers together to send out to everybody afterwards. So on to the first topic, the early AI limitations. So a few years ago, I'm sure everybody would remember AI models were pretty much limited to their training data and then whatever context you provided. So if you wanted to analyze, say, a specific donor who wasn't in the model's training data already, you had two main options to handle this. You could hire a technical team to build custom AI agents with custom tools, which would take a considerable amount of time and resource to achieve. More so if you wanted maybe that AI agent to pull in data from multiple external sources, or you could manually copy and paste any relevant data you wanted into the model to know about alongside your instructions. Neither option was super ideal for practical workflows and workflows that went kind of well beyond a small amount of information. So that's when kind of tool calling came along as the first step solution. And this has changed the AI landscape. Now AI models can decide when they need external information, automatically fetch that data from external sources, and integrate the results into their responses. You've probably already seen this in action. So for example, through AI support agents that might be able to check on your account status, or ChatGPT being able to search the web for current information. This is all forms of tool calling. But how's tool calling working behind the scenes? AI models are provided with a toolkit containing descriptions of available tools and instructions on how to use them. The model decides which tools are relevant to a user's query and is able to call them automatically. Here's where the current tool calling hits a wall. Let's say I want to build an AI agent that connects to my RENXT account to fetch constituent information. The current process with traditional tool calling would involve choosing an AI model like Claude or one of the OpenAI's GPT models, for example, using that model's specific tool calling API framework, and then coding custom tools for the RENXT integration, and then finally bundling all of that together into a nice package that you can use to interact with the AI and all that fun stuff. The problem is if I decide I wanted to switch this agent from using a GPT model and instead have it use a Claude model, for example, I would need to rebuild this agent using Claude's different API syntax. So you can kind of think about this as similar to electrical outlets. So normally you can plug in any device, a vacuum, laptop, TV, into the same standardized outlet. But with the current tool calling methods, it's like needing a different plug and outlet for every combination of AI model and data source. And while this works, it's not super sustainable for widespread AI adoption. This is where Model Context Protocol, or MCP, really shines. MCP is a standardization for tool calling that the industry has kind of been waiting for, I think, at this point. It's like creating a USB-C for AI integrations, one universal connection that would work anywhere. What MCP enables, so imagine an AI assistant that can pull a specific constituent's data from RENXT, cross-reference this data with CharityCAN data, for example, draft a comprehensive prospect report, and save it as a Word document to your computer, all from a single prompt, maybe something like create a cultivation strategy for John Smith. This is what MCP aims to basically make capable. Or make doable. But really, what is MCP and why is it a game changer? MCP is made up of three main parts. You have your MCP host, which is your AI application, like, for example, Claude Desktop or a custom AI agent. You have MCP client. This is the universal adapter that manages connections between your AI and external tools. And then you have an MCP server, which is external data sources like file systems, CRMs, databases, etc. These are servers that your external data sources would set up. So maybe RENXT would set one up, and it would have all of the tools available that your AI agent would use. This means that instead of custom coding each integration or tool that you would want your AI agent to access and use, like what is commonly done currently or has been commonly done up until this point, data providers would simply build one MCP server. For example, again, with that RENXT, they create an MCP server with tools to fetch and write constituent data. Your AI agent would connect via a standardized protocol instantly, and then your AI can just access those tools without any custom tool development that you would have to do to get that RENXT integration working. And if you wanted to switch from another model, so you set up your agent with GPT and you wanted to switch to Claude, that's no problem. The same MCP connections work with any compatible AI model. And so that was like a little crash course, I suppose, as far as how MCP kind of is aiming to standardize the what and how of AI tool integration. But how do these models actually learn to reason about when and how to use tools effectively in the first place? That's where reasoning model training comes in. Reasoning models are LLMs, or large language models, trained with reinforcement learning to perform reasoning, enabling them to think before they answer you. The key difference, reasoning models add reasoning tokens. Essentially, they think out loud internally before responding to your query. So while traditional models just have input and output tokens, reasoning models use these extra tokens to consider multiple approaches to your request. This means that a reasoning model can take your prompt and available context like tools and conversation history, generate multiple possible approaches using reasoning tokens, capture nuances in your request, determine the best solution, and decide which tools to call upon, if any. It can even correct itself along the way and then finally deliver the optimal response to you. Here's a perfect example. I asked ChatGPT earlier to explain reasoning models to me in 2 enthusiastic sentences, but without using any words that contain the letter S. You'll see in this screenshot the reasoning chain the model uses with 4 different turns. So turn 1, the model identifies the challenge, create 2 exciting sentences while avoiding the letter S. Turn 2, it explores possible solutions. Turn 3, the model catches that its previous solution contained the letter S in the word answer and decides it needs to rewrite the solution accordingly. And then turn 4, the model reinforces its decision and approach, resulting in a final output of a somewhat caveman-like explanation, but it's one that perfectly meets all of the requirements we set out. And I assume words with that sentence structure without the letter S is pretty hard to not make caveman-like, so did pretty well. This reasoning capability transforms tool usage. For example, with tool selection, instead of randomly picking tools, reasoning models can evaluate options and choose the best combination for complex tasks. It also, just extending on our example in the last slide, reasoning models can catch mistakes and try different approaches mid-process. This makes reasoning models capable of handling more complex workflows. They can break down multi-step requests, like create a cultivation strategy for John Smith, into something that would be structured like this. So they would make a decision to call on a tool that fetches, say, constituent data from RENXT. Then it would analyze the giving patterns. Then it would draft a personalized strategy, and it would decide to call on a tool to perhaps save this as a formatted document. Reasoning models also understand when not to call on tools. For example, knowing the difference between when the user is asking, "What's the weather?" Where the model would have to decide to call on a tool to do a web search for up-to-date location-specific weather reports, versus maybe a question like, "What's photosynthesis?" where it would decide it could simply just use its training data to answer that question directly without calling upon any tools. In summary, this results in powerful AI agents that don't just follow scripts, but actually think through problems and adapt their approach, making them capable of being great tools for, again, more complex tasks and workflows. With all of that said, we have an exciting new feature that we at CharityCAN have been working on, which is an in-app AI prospect research assistant. This chatbot puts everything we just discussed into practice. So it's powered by reasoning models that will think through your requests. It has tool calling capabilities, allowing it to run CharityCAN searches and return results back to you according to what you're looking for. And it's also context aware, so it takes into consideration your conversation history with it, and then also your settings in CharityCAN, like your default organization that you've set and your cause that you've set as well when providing replies. I also have a quick demo video here of this chatbot in action. Let's see. Oh, it's already playing. So to start the conversation, I asked the assistant to tell me about James Balsillie. What will happen in the background is it will decide that it needs to call on 2 CharityCAN tools to get the required information. It will use the CharityCAN's profile search tool to find relevant individual profiles in question. So you can see it there. It's just found the James Balsillie result in the profile search. And then it will go ahead and fetch that profile's details and then pull them back in as a response for the user to review. So looks like it's just finishing that up right now. Takes a couple of moments, especially with James Balsillie. He has a fair bit of information on him, so to summarize and make look nice. So, oh, there we go. So you'll see that based on the profile data, the bot has been able to output pretty comprehensive overview showing up here for James Balsillie. And then in the tool call responses as well, there's links to the full search that the chatbot decided to use to get those initial profile results in case you'd like to cross-reference that, as well as the link to the full profile it is actually sharing with you. And it's picking out pieces of information from the profile that it thinks is relevant according to what you've asked. This assistant is also able to pull in charity and corporate profile data in much the same way. It can also run donation record searches, and we're planning to expand the assistant's tool set to be able to call upon CharityCAN's different searches, all of CharityCAN's different searches as well. And you'll see later on in this demo here, now that the chatbot has that profile data initially, I was curious to know if the assistant would recommend I do some further prospect qualification, or if I should do some further prospect qualification for James, and why or why not. And then in its response, it's able to remember that it learned about James Balsilli's profile earlier on in the conversation. It takes into consideration my default organization. In this case, I set it to Tree Canada, and I believe the cause I set was environmental or agricultural related. And it was able to give me a capacity, propensity, and affinity overview, with the affinity overview highlighting why James might be a relevant prospect for, in this case, Tree Canada, based on donations that he made to environmental causes in the past. The assistant even offers some next step suggestions and how I might be able to approach further prospect qualification with James. And yeah, that's basically a little bit of a demo, like I said, of what we have in the works right now. This is a feature we hope to roll out as a first version of in the upcoming couple of weeks. And then when everybody has had a chance to try it out, there's also a feedback option right there in the chatbot that will allow you to provide any bug reports, feature suggestions, questions, comments. And of course, we would love to also hear your suggestions and questions before the launch as well, if you have any, which we would be excited to talk about. Yeah, that basically wraps up our office hours webinar for today. Now we can open up the floor for some Q&A and discussion. So if anybody has any questions at all about what we discussed today, please feel free to leave them in the chat or ask them live.
That was absolutely fantastic, Grace. Thank you so much for walking us through first, like the overview of how tool calling works and AI agents, and then previewing what we're calling CharityCAN GPT for now. Who knows what it is when we turn it live? That's what it is for now. I hadn't even seen it personalize the plan based on the default organization, Tree Canada, in that case. So my jaw dropped a little bit. I had my camera on, my mic was off. So I was really impressed with that, because that was new to me as well. So yeah, fantastic stuff. If anyone has any questions or comments about anything we looked at today, or anything in general, drop them in the chat, and we'll do our best. We'll do our best to answer them.
Sure.
Yes, William, there definitely is. We can get you a copy of the slide deck, and I'll send out a recording of this webinar to everybody that was on the meeting. Shane, does this give you references as to where it got the information? Grace, I think you're probably best positioned to answer that question. I've got a good idea, but I don't want to slip up.
For sure. So if you're talking about the chatbot, like the CharityCAN chatbot, all of the information that it provides you is actually based on either its training data, so publicly available stuff on the internet, which is most AI training data, stuff like that. But also it's based on CharityCAN tools itself. So like what you had seen in the demo, if somebody's asking a question about, say, James Balsilli or another individual, corporation, foundation, it will actually search in CharityCAN first and use that information as a source of truth. And it won't depict or divulge any information that is untrue or inaccurate in that sense.
Thanks for those two questions, folks. Fantastic stuff. If anyone else has any more questions, yeah, just drop them in the chat or the Q&A.
I'd be curious to know what people think the perfect prospect research assistant would be able to do for them, and why. Because, you know,
yeah,
features.
Yeah, if anyone has anything like that, like exactly what in a perfect world would you like an AI agent virtual prospect research assistant to do for you? Do not be shy to let us know. That would help us immensely as we develop this tool further. For sure. Email, anything. Jason, fantastic question, and one that we were talking about in our team's stand-up meeting this morning at 10 a.m. That's very that's very on the nose of you to ask such a question. Yeah, potentially, definitely is the answer. It got some thumbs up in the meeting. I know that, but again, we just broached that topic about 4.5 hours ago. Fantastic question, though. Your head is right where our head is at.
Yeah, for sure. Like that was definitely something on our mind, creating a CharityCAN MCP. And I think a lot of different data sets too. Like it's starting to pick up traction because it's so universal, or a way that is introducing a universal connection to different tools. So hopefully a lot of other data providers also start implementing that.
Well, it looks like that might be everything for questions, which is totally fine. Those were some very valuable questions that we really appreciate. That allows us to kind of clarify where we're at a little further. Like I said, we can circulate the slide deck. We can circulate the recording. I've also got a list of folks that asked for a recording that couldn't make it, so I'll have to do that anyway. Thanks for taking the time to attend, folks. We really appreciate it. We're going to keep this series ongoing. And like I said, if you have any ideas about what a perfect prospect research assistant would look like, please do not hesitate to let us know. We build this stuff for you folks to use. So any help you can give us is greatly appreciated. Thanks for spending the time with us, folks. Have an awesome day. Bye.
So have a great day, everybody. Thanks for attending.